Okay, so let's practice another one. This is number 17 in 2.2. So we did 14 already, so let's try 17. And again, we're given another higher order, right? Homogeneous differential equation, right? Notice this is a third order again. And we're given initial conditions, right? Notice we have the second derivative here because we're working with the third order. And we're given three linearly independent solutions. Okay, they have to be independent rather than dependent. And the problem says, let's see, third order homogeneous, given. Okay, so the goal is to find a particular solution satisfying the given initial condition. Well, they give us, again, they give us a lot of information. I mean, obviously they're asking us to find a particular solution, so they have to give us this initial condition. But they give us these three linearly independent solutions, and we know, let me move this up, given these three linearly independent solutions, we know that our general solution, right, we called it capital Y of x in the last one, or y of x, is going to be C1, well, let's just write the general, C1y1 plus C2y2 plus C3 y sub 3, right? Because remember, n is 3 because we're working with a third order homogeneous equation. So we have, we have C1, well, there's y1, well, times 1, plus C2 cosine of 3x, right? And then y3, which is C3 sine of 3x. Okay, so there is our general solution to our homogeneous differential equation. And we're actually going to be calling this guy y sub c, which is the complementary solution. We're going to be calling that when we work with non-homogeneous equations, which you'll have in on number 22 of the section, and we're going to do a ton of non-homogeneous equations in 2.3 and 2.4, and I mean this whole chapter. But for now, that's, again, if this is confusing right now, you'll see it later. Okay, so let's impose, right? So imposition of initial conditions. So we know we're going to differentiate at least twice because there's a second derivative. So we have, excuse me. Okay, so here's my y of x. And so y prime, okay, well that's just c1, which is a constant. Derivative is 0. The derivative of cosine 3x, well, that is negative sine times 3, so that's going to be negative 3 c2 sine of 3x. And then we have, this is going to be 3 c3 cosine of 3x, right? I'm using the chain rule. And y double prime, right, because we have our double prime there. Let's see, that's going to be negative 9 c2 cosine of 3x. And this is going to be negative 9 c3 sine of 3x. Okay, so now let's go ahead and use the initial conditions now that we have our derivatives. So we have y of, well, first y of 0, which is 3. Okay, so y of 0, so I'm looking at this guy right here. So that is c1 plus c2 cosine of, well, 3 times 0 is 0, plus c3 sine of, again, 0. And all this is supposed to give me 3, right? Y of 0, yep, is 3. Okay, so what does this imply? Well, this is c1 plus cosine of 0. Remember, at at the angle 0, the cosine is 1. So this is just C2 plus, well, this is nice. This is just 0, so technically we don't have to write plus 0. Let me just erase it. So it looks nice. Okay, equals -3. So we've generated a nice equation in two variables. Let's do the same thing with y prime of 0. So y prime of 0, so now I'm looking at this guy, and that is -3c2 sine of, again, 3 times 0 plus 3c3 cosine of 0, and y prime of, whoops, of 0 is, y prime of 0 is -1, right, from our initial conditions, equals -1. Okay, so what does this imply? Sine of 0 is 0, so this whole thing is 0. Then we get, well, cosine of 0 is 1, so that's just 3 C3 equals -1. And that implies C3 is -1/3. Now let's use our last initial condition, which is our y double prime of x. So y double prime of 0. So again, I'm using this guy right here. So we have, whoops, equals -9 C2 cosine of 0 minus 9 C3 sine of 0. And our, let's see, what do we get? Y prime double prime of 0 equals 2. Okay, so this guy should give us 2. So what does that imply? Well, we know sine of 0 is 0, so that's gone. And we get negative, well, this is going to be 1. So -9 C2 equals 2. And then, of course, if we solve for C2, we get -2/9. Okay, so we have C2 and we have C3. So we can definitely, well, we can find C1. I mean, we don't even, we already have C3. So let's use, so C1 plus C2, which in this case is -2/9 equals -3. And let's see, solving for C1, the solution is 29/9, but I'm not going to get 29/9. I'm going to get 25, -25/9. So let's see if there's an error somewhere here. A negative, oh, I think I see it. Y of 0 here is 3, and I have -3 there. So that is not supposed to be there. That should be +3. And so this guy is +3. Okay, that should fix it. So we have C1 equals 3 plus 2/9. Whoops. And that's the same thing as 27/9. There we go. And 29/9. Okay, so we found our C1, C2, and C3. So therefore, our desired particular solution, so YP, or YP of x, is, or the book actually calls it Y of x. So let's be consistent, I guess. I mean, it is YP, but Y of x equals, let's see, so we had our let's write our, okay, C1 plus C2 cosine of 3x plus C3 sine of 3x. And we can write those parentheses or not. So again, I'm going back to my original general solution. Right, I get the pointer. I'm looking at this guy right here. So now I found my C1, C2, and C3. So I'm just inputting my coefficients. So almost done. Okay. Okay, today's not. Okay, y of x equals c1, which is 29 over 9, plus c2, and our c2 was, I believe, negative 2/9 cosine 3x, and our c3 was negative 1/3, so technically you can just write minus 1/3 sine of 3x. And this is fine, the solution's correct. The back of the book has something a little different. It's just, they just simplified it. What they did is, okay, so they said they wanted to combine fractions, that's all. So this is really 29 minus 2 cosine of 3x. Okay, that's really over 9, minus sine of 3x over 3. Again, they usually want it in simplified form. Well, you can, do times 3 times 3, right? Just adding fractions. So we get 29 minus 2 cosine of 3x minus 3 sine of 3x all over 9. And again, I wrote my 3 here and not here because I don't want you to get confused and do 3 times 3. That's why I like to put the parentheses there, because again, this is a specific angle. And that is it. That's the final answer. And again, we're going to practice a lot of these in section 2.3. 2.2 is, again, it's higher order differential equations, homogeneous differential equations, and again, we're going to be finding these C1s, C2s. We're going to get a lot more practice. So hopefully that makes sense. If you have any questions, again, just ask a question on the discussion board. Hopefully somebody answers it. If it doesn't, I will definitely jump in.